Okay, good morning, students. So, this is my new web series. Planning to have or host a series of around 200 to 300 episodes on this, which basically deals with something known as misconceptions in physics. Misconceptions in physics. Now, what are these misconceptions? Misconceptions are those wherein the concepts are not being understood properly. Or even though if you have understood something, but still you make a mistake while you solve a problem. This is called as misconception. So in physics, there are several such concepts wherein initially we think we have understood it, and then we look at it and say we make a mistake, and thereby we realize that we have not understood the concept correctly. Okay, so such kinds of concepts, what we need to do is we need to look at how to solve a problem incorrectly and also look at how to solve it correctly. Both the things we need to look at. So I have observed when I correct several papers in physics of various grades, there are some specific problems which I observe that people or students makes lots of mistakes. So such problems I have categorized it and I have put it across into a separate database. So I'm planning to do something like around 365 problems. 1 year is my target. Okay, from various branches of physics and post it across. So the result is this. I already have around 200 problems categorized like this. The rest of them I need to still look into as what are the types of problems which the students will make mistake. It's something like if 100 students are writing a problem, attempting a problem, maybe around 50% of the time the students are making a mistake here. Of course, there are students who learn the concepts appropriately and don't do any mistake. But most of the time, if they make a mistake, such problems I categorize it separately. Okay, now let us begin with the first problem today. Each episode or each video is only for maximum 5 minutes, not more than that. Okay, a body moves in a circle of radius 3 meters. See, 3 meters it moves. Radius is given to you. Radius is given to you. Okay. At a speed of 6 meters per second, constant speed, which means what? The speed here is 3 meters per second. The speed here is also 3 meters per second. Speed here is also 3 meters per second. Why did I write it? Because it's a constant speed. Wherever you take, it's a constant speed. The body starts at A. It starts at A, proceeds to B. It moves in a circle like this, goes to B, then to C, then it comes to C. Find the change in the velocity vector between A and B and between B and C. Okay, this is what is the question. Most of the time, when I ask this question, I can either ask this question as find a change in velocity vector or acceleration vector. The answer that I get is something like this. Now, what do the students do? The students generally, what they do is, given two vectors, one vector is like this, other vector is like this. See, this vector is like this vector is like this. I wrote it like this. Since they are perpendicular to each other, they just write down the resultant of this one like this. And they say, this could be the right answer. And the answer here is root 2, 3 root 2. Okay, this is what is the answer I get. Similarly, if I consider the resultant between these two, this vector is going like this. This vector is going like this. This vector is going like this. Okay, so when I take this one parallel over here, I can now say I can put it like this. I can put it like this, and thus I will get a resultant vector like this. This is not right one. Not right one. Okay, so I get a resultant vector like this. So the resultant of BC, they write it like this. But I can say that both these answers are incorrect. Okay, why? Because the question asked here is change in the velocity vector and not the resultant vector. Now, if I consider this as VA and VB, now when I say change in velocity vector, I am talking about VB minus VA. Okay, which means what is VB? I will just write VB like this. See, I will write VB like this. Just VB is like this. And what is VA? VA is like this. But this can be written as VB plus of minus VA. Right? When I say minus VA, then this VA should have been like this. Right? VA is like this. So VA should be opposite over here. This should be your VA. So in other words, the sum of these two should look like this. VB is written like this, and VA should be, how should VA be written? It should be like this. This should have been VA. That's not VA, it's minus VA. Minus VA. Now if I add these two, then this should be my answer. Right? VB plus minus VA should be VB minus VA should have been this. Okay, so therefore, if I take this particular arrow and draw it here, this arrow would have been like this. This arrow would have been like this. If I divide this by time, now what do I get here? We already learnt that VB minus VA divided by T is nothing but your acceleration. Now you see, the questions can be framed in two different ways. First one is, I can frame the question like this. Or I can also ask the question as, what is the acceleration of the particle? When I say acceleration of the particle, I get two different answers once again. See how crucial is this concept. Okay. The first answer people generally say is, if it is a vertical velocity, okay, vertical circle, then they say the acceleration should be equal to 9.8 meter per second square, which is equal to g, which is totally incorrect. Why incorrect? Because the value of g is always pointing downwards. It's always pointing downwards towards the earth, right? So it cannot point to something like this, which is impossible. Until and unless this is a satellite and this is the earth. But we are now considering a small point particle on the earth. So this is never equal to g. Next question, next answer I get. Okay, what is the acceleration for this particle? Next answer I get is, I get an answer equal to 0. Why 0? Because what they do is, they say acceleration is final velocity minus initial velocity. V minus u divided by t. V is also 3 meters per second. U is also 3 meters per second. I substitute it and finally get it as 0. Now the mistake that they make here is that acceleration equal to V minus u by t is considered in such a way that this is your acceleration vector and this should be vector V minus vector u here, which they don't consider. And once we get this, then we take the magnitude of this and finally we find out. So this is the mistake which most of them do. So where does this mistake arise from? From this concept. Remember, what is the important concept here? Velocity is a vector. Okay. Whenever I talk about velocity or whenever we talk about vectors, remember, whenever we talk about vectors, if we are adding two vectors, just don't add the magnitudes. If I give you a vector, vector A equal to 3 units and vector B is equal to 4 units, A plus B is equal to 3 plus 4, which is 7 units. Okay. This is the algebra of it. But if you take it vectorially, you should ask the question, are those vectors in the same direction? Are they making an angle? Are they opposite to each other? This is something which we need to ask. If we get an answer to this question, only then, okay, we will be able to add two vectors. Otherwise, you cannot add it. Now, what is this concept on? Addition of two vectors. Okay, see, the addition of two vectors now leads to a circular motion. You can employ this addition of two vectors in vector addition in case of kinematics, mechanics, everywhere. So the major concept here is understanding of the addition of vectors. Okay, just don't say vector A plus vector B, I can do it. But you should be able to apply that addition of vectors in circular motion to understand how do you calculate the acceleration, right? Now for this question, you see the change in the velocity vector is directed like this. So this should be now your VB minus VE. Now if I ask you what should be the change in velocity vector here for the second case, VB and VC, what should be your answer? What is VB? Now you have VB downwards like this, VB downwards like this, and VC is downward up in this way. Now what do I need? I need change in velocity vector, which is VC minus VB vector. I need something like this. Okay. So therefore, now VC, now you see this vector, the second vector, I'm going to retain it like this. I'm going to retain it like this. VC, I'm going to retain it like this. VB. Now VB becomes minus VB. This is plus VB. What is minus VB? Minus VB should be in the opposite direction. So I am going to remove this. So resultant of these two, what is this now? This is minus VB, this is VC. The resultant here should give me VC plus minus VB. See, this should give me VC plus minus VB. This should be equal to VC minus VB, right? Okay, most of them, if you ask them this question, they will definitely write 3 root 2, but they fail to write what is the direction. Okay, very simple concept. Okay, I hope you understand this. Thus, the resultant vector here should be like this. Now, notice one more thing. This leads to one more concept here. It says that the change in the velocity vectors is always directed towards the center. What does this tell you? The change in velocity vector is directed towards the center. And if you divide this by time taken, you get some acceleration here. What is that acceleration called as? Centripetal acceleration, right? Now I hope you understood the concept of centripetal acceleration. What is centripetal acceleration? The acceleration of a particle moving in a circular path, which is directed towards the center, right? It is directed towards the center. This is your centripetal acceleration. Okay, we'll stop here. In tomorrow's video, we will look at one more concept, on vectors. Thank you.